Okay, so we want to select all of the following transformations that would map the figure onto itself. When we say map it onto itself, map onto itself. If you say map onto itself, that just means that it has to land exactly on top of itself. It's got to land exactly on top of itself. So it says select all that apply. So if someone says select all that apply, that means you have to try every single one of them to see. So this is all that applies. So I have to check A, B, C, D, E, F, G and see which ones of those are going to work out. So let's try a reflection across the x-axis. So the x-axis is going across here. So that means this axis right here. So if I was to reflect this over it, it would be down here. So this point would come down here, this would be here, and this would be here, and I would end up down here, right? That is a reflection across the x-axis. So is my orange parallelogram sitting right on top of my blue one? No, it is not. Since it is not, this is not okay. So it is not going to land on top of there. And I'm going to be erasing these in between here so you can obviously see what's going on. The next one, it says I'm going to reflect across the line y equals 6. So the line y equals 6 means that I need to go onto my y-axis, y equals 6, go to my y-axis and go to 6, which is right here. And it's going to be a horizontal line right there. Remember, a line that says y equals, we always mess that up because if you think about the y-axis, that's going up and down, right? But when you have y equals a number like 6, it's going to be going this way. So it's kind of backwards in your brain. So try to remember that. So just because the y-axis goes up and down does not mean y equals 6 does. So that's this line right here. So the question is if I were to take this, trace this, and fold it on this line, would this land on top of itself? And we could see it's not gonna, because watch this. Because if I go to reflect this over, that's 1, 2, 3, 4 spaces. 1, 2, 3, 4. So, oopsie. My C prime is going to be here. If I take this B, 1, 2, 3, 4, 1, 2, 3, 4. That's going to be my B prime. My D is going to be here. My A, 1, 2, 3, 4, 1, 2, 3, 4, is going to be here. So that means my new shape is going to look like this. Did that land right on top of the other one? No, my orange one is not right on top of my blue one. So this one is not going to work either. Nope. Okay, let's think about a translation. If I take this whole shape and I translate it, 8 units up and 6 units to the right. So that means I'm going to take each one of those 4 points and move them 8 units up. So let's take this B. 1, 2, 3, 4, 5, 6, 7, 8 units up and 3 to the right. 6 to the right. 1, 2, 3, 4, 5, 6. So my B is going to land here, right? Where's my C going to land, though? My C is going to be going up 8, way up here in the sky, and over 6. So it's going to be like way out there, right? My D is also going to be way out there, and my B is going to be, my A is going to be like here, right? So my shape is going to be way up here, going off of my screen, right? It's going to be like coming up like this. So can you say that this yellow one land on top of the blue one? You would say no. It's clearly way up higher than the blue one. If you take a shape and you move it, it's not going to land on top of it if you're moving it up like that. So this is going to be a no. Okay, a rotation 180 degrees about point A. So that means if I was to take a piece of patty paper, I take my piece of patty paper and trace this shape. Pretend like I have a piece of patty paper over top of this. Try to visualize it. If I were to hold it down on A, right here, if I was to hold it down A and spin it 180 degrees, that means spin it around here. Will it land on top of this same green guy? It would not, because if you spun it around, he would be down here, right? Whoopsie. You would see him way down here if you spun it around. Oopsie, that's not even the way. I can't even draw it on the screen. But anyways, it's going to be way down there. It's not going to be landing on top of itself. So that one is not going to work out either. Okay. That is going to be no. Okay, want to rotate 90 degrees around the point 10, 6. So 10, 6, that's over 10 and up 1, 2, 3, 4, 5, 6. That's about right there. And I want to rotate just 90 degrees. So same thing. If I trace this and I think about spinning at 90 degrees, so I could think about an XY axis. So if I trace it and held it right here on this red dot and spun it 90 degrees, it wouldn't even matter, because if I took this and spun it 90 degrees, this pointy thing would be coming out here, sticking out this way, right? And even if I went backwards, the pointy thing would be sticking out that way. So you can always trace it and spin. This one is not going to work out either. Okay, next one I have to check out. It's going to be a reflection across the line BD. So BD would be a segment that connects B to D. So that's going to be this line right here. So if I were to reflect it, in other words, if I were to reflect over this line, think of this line longer. So count this point, blah, 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 envision it, count it here, and keep continuing it over here. It looks like it probably would, and those would land on each other, and the B and the D would be fine. Or if you were to trace this and fold it right down this line BD, that I'm making in purple, would each of these sides match up to each other? And I believe this one's going to work out for you. The last one is a reflection across the line AC. So AC would be this line. So if I were to fold this across, it would land over here, and that one would land over there. So probably these two are going to work out for you. You can trace that and double check it to make sure that it works out. But it looks like when I'm looking at it, it will work.